The VII California program is a successful and unprecedented initiative for vehicle infrastructure integration. The project brings together public, private, and academic partners under the leadership of Caltrans and the Metropolitan Transportation Commission, or MTC. Recently, the ITS Joint Program Office of the U.S. DOT has recognized the leadership, innovation, and significance of the project by officially including it into the federal VII effort. The VII California testbed, which is located on the San Francisco Bay Peninsula, has been in operation for nearly 2 years and is the nation's first realization of VII. Auto industry partners, including Daimler Chrysler Research Engineering and Design North America, Toyota Info Technology Center, and Volkswagen of America Electronics Research Laboratory, have joined with Caltrans and the MTC to develop applications that use the testbed. Support for the infrastructure development is provided by ITS researchers at the University of California PATH program and by Telvent Faradyne, which operates and maintains the San Francisco Bay Area's 511 system. The first phase of the program was completed during the 2005 ITS World Congress in San Francisco. The VII demonstrations showed that a small fleet of vehicles could engage in a wide range of ITS applications using wireless messaging, roadside radios, and Internet services. The VII California testbed now has 12 roadside equipment installations at freeway and arterial sites, with 28 more installations planned for the next year. Essential to VII is the vehicle-to-roadside communication provided by DSRC radios. DSRC, or Dedicated Short-Range Communication, transmits on the 5.9 GHz band, which is reserved by the FCC for safety and informational applications on vehicles and roadside equipment. In the VII California testbed, these DSRC radios are installed together with host computers in existing signal controller cabinets. This design provides electrical power and allows the system to access signal phase and timing data, as well as data from other devices such as GPS receivers. Test vehicles are equipped with radios and antennas for receiving DSRC messages from the infrastructure. In this demonstration, signal phase and timing information is received, then displayed in the vehicle. The in-vehicle display changes synchronously with the signal head that faces the driver. By using a signal sniffer to detect changes in signal phase based on their electrical current, the signal messaging system is also compatible with legacy signal equipment that does not have a digital interface. By combining the DSRC broadcast with in-vehicle sensor systems, the user interface can warn the driver about a potential signal violation. DSRC can also send data from one vehicle to another vehicle. In this demonstration, vehicles send emergency braking messages. The in-vehicle display integrates these vehicle-to-vehicle safety messages with the infrastructure safety messages.
Warning, red light! Warning, red light! Warning, red light!
Traveler information systems, such as this 511 control center located at the Caltrans District 4 office, generate up-to-the-minute data that are of great benefit to drivers on the road. The Bay Area's 511 currently disseminates information to travelers via the phone and the 511.org website. But how can infrastructure operators get this critical data into the vehicle quickly? This is the power of VII. The VII California testbed has accumulated experience with a wide variety of backhaul communication solutions, from cellular data modems such as GPRS and 3G to landlines ranging from DSL to T1. The backhaul connects the 511 center and other Internet services with the roadside equipment. Information is ultimately transmitted from the roadside to the vehicle using DSRC. For each installation site in the testbed infrastructure, The MTC server generates a set of customized speed limit messages, which are broadcast to vehicles within range. Messages can also inform the driver about other transportation modes. This message indicates commuter train arrival times at a nearby station. Time-critical and location-critical messages, such as this incident message, can be delivered to the drivers as they approach the affected area. 511 travel times are also available through the VII roadside equipment to drivers with DSRC radios. By connecting vehicles to the network, VII brings a vast and yet untapped source of data to the Traffic Management Center. The data shown here come from in-vehicle sensors. The VII system collects the data into traffic probe messages, which are relayed through the roadside unit to the TMC. The messages are processed at the TMC and can be visualized as in this real-time display. Messages contain information about the location, speed, heading, and status of onboard devices, but no unique information about the vehicle or the driver is collected. Anonymity and privacy are a key component of the system. Live probe data from the VII system can be used to generate traffic data on arterials where 511 does not have coverage. This data can be fed back into the system as travel time messages, benefiting drivers who use the system and, in effect, rewarding them for contributing their probe data. Indeed, VII California is a significant collaboration of can-do teammates, public sector, private companies, including a host of automotive companies, and academia. This can-do attitude has already resulted in groundbreaking and noteworthy lessons learned to benefit California and other U.S. regions alike. And our work is not done. The VII California testbed is expanding, with a network of DSRC roadside units and a heterogeneous backhaul network with T1 wireline, 3G modem, and coming online WiMAX. VII California is now integrated with the federal VII effort, all the while developing interesting, innovative applications for the region and the nation, ranging from mobility applications such as the use of probe vehicles for traveler information on virtually all roads, on-ramp metering and enhanced methods of tolling, to safety applications such as intersection safety and curve overspeed warning. In the end, VII California aims to combine the resources, expertise, and innovations of the public sector, the auto industry, aftermarket suppliers, and other private sector participants for the benefit of the traveling public.